everyone, welcome back to another video, and in today's video we are building a complete shape detection system using OpenCV in Python. In this video we will detect multiple shapes in a single frame, draw their boundaries, classify them as a triangle, a square, a rectangle, circles, and display small label boxes above each detected shape. So without wasting any time, let's just dive into it. Normalizing and resizing the feed. We begin by importing OpenCV and NumPy. OpenCV is the main computer vision library that allows us to process the image. We'll make sure that the path of the image is in the same directory of our code file, and afterwards we will read the image through the image path, and we'll make sure that the image path is valid, and if it's not valid we will simply exit the program by printing image not found. After loading the image, we resize it. Why resize? Images can come in a very large resolutions. Processing large images increases computation time and can make control detection inconsistent. Resizing standardizes dimensions, improves processing speed, and make area thresholds predictable. Grayscale metrics. Next, we convert the image from BGR to grayscale. For shape detection, color is not important, and grayscale reduces complexity and makes edge detection more accurate. So we will convert it from BGR to grayscale. Gaussian kernel. Now we apply Gaussian blur. Real-world images contain noise, tiny variations in pixel intensity. If we skip this step, canny edge detection might detect noise as edges. Gaussian blur smooths the image and reduces false edges. After edge detection, we sometimes apply a technique called image dilation. Image dilation is a morphological operation. Its purpose is simple. It makes white regions thicker. In other words, it expands the boundaries of detected edges. Canny gradients. Now we'll move on to the step of contouring the image. We use cv2.find contours. Contours are continuous boundaries curves around objects. This function scans the edge detected image and extracts each closed boundary as a separate contour. If there are 5 shapes in the image, we get 5 contours. We use retr external because we only want the outer boundaries, not the inner nested contours. Next, we loop through each detected contour. This allows us to process each shape individually. And then we'll start off by filtering small areas. We calculate the area of each contour. Why? Tiny contours may represent noise or imperfections. We ignore contours below a threshold to ensure we only classify meaningful shapes. This improves the accuracy. We then calculate the parameter using arc length. The parameter helps us to approximate the shape's geometry in the next step. Polygon approximation. We use approx poly dp to approximate the contour. This simplifies the contour into fewer points. For example, a triangle becomes 3 points, a square becomes 4 points, and a pentagon becomes 5 points. This is the mathematical core of shape detection. We are not using AI, we are using geometry. Counting vertices. We count the number of vertices. If it's 3, then it's a triangle. If it's 4, then it's a square or rectangle. To distinguish square from rectangle, we calculate the aspect ratio of the bounding box. If width and height are nearly equal, it's a square. Otherwise, it's a rectangle. If vertices equal 5, then it's a pentagon. And if vertices are greater than 5, then it's a circle. It's up to you, you can add more images if you want to. This is rule-based classification. Next, we'll count shapes. We use a dictionary to count how many times each shape appears. Each time a shape appears, it is detected. We increment the count. This allows us to display a summary if needed. And then we will move on to drawing contours. We draw the approximated contour on the image. This visually outlines the detected shape and confirms that our detection logic works. Now we create a small black rectangle above the shape. We first calculate text width and height using getTextSize. Why? Because we want the rectangle to perfectly fit the text. Then we draw that rectangle slightly above the bounding box, and finally we place white text inside the black box. This improves readability and makes the output look professional. And finally we display the processed image. Now the image contains clean contours, small labeled text boxes, multiple shapes detected independently, and this confirms the system works for multiple shapes in a single image. I also tested it with the different image as well, and as you can see that the image input has triangles only, and it automatically detects all of the triangles. So that was it for today's video. If you liked the video, give this video a huge thumbs up and subscribe to the channel. Thanks for watching.